Hey guys, today we'll be talking about one more important thing before we actually go down to solving the real deal, the real graphic problems, and that is called area under a graph. Now you will ask me, Adil, why do we even need area? Because we have graphs there, we have just seen how to find a different thing from a velocity. We know how to find acceleration from velocity. We know how to find the velocity from a displacement time graph by gradient. Why do we need area? So I will tell you, not so fast, guys. Just wait and watch, because we can use the same principle, the same idea, and find a different quantity again from the same graph. Let's see here. For a graph, if this is my graph, what do I mean by area under the graph? This is any quantity here. What do I mean by the area under the graph? For example, if this is my line of the graph, I ask you to find out the area under the graph. What am I exactly telling you to do? I am telling you to find out this area that it has with the x-axis and the y-axis, the area covered by this line. This is what I'm telling you to do. Now, if you can see closely, in this case, it is a rectangle. And the area of a rectangle is given by, if you know your arithmetics properly, the area of a rectangle is given by length times the height, or the width. So in this case, this is the length of the rectangle. Let's say this is the width of the rectangle. So I'm just simply multiplying this number, the distance from here to here, and the distance from here to here. So what am I doing exactly when I'm doing this? I am multiplying a quantity on y-axis with a quantity on x-axis. This is what I am doing. I am multiplying the quantity on y-axis with a quantity on x-axis. Let's take an example, and then I will tell you how you do it. It will be clearer to you then. Let's say I have a graph here. Okay. Let me make another graph here. Just clear it up. My pen can act weird sometimes, so ignore that. It is acting weird right now. Anyway, so let's say this is the graph, and the graph is a velocity time graph. And I ask you, velocity is in meters per second, sorry, and time is in seconds. I ask you to find the area under the curve. If for example, this is at 6, and the time taken for this entire journey is 8 seconds. This is the journey. You can see it's a velocity time graph. The line has only one velocity, and it's moving with that same velocity. So throughout the journey, the car moves with a 6 meters per second. It's not accelerating, it's at constant velocity. We call this constant velocity. Now if I ask you to find out the area under this line or under this curve, we actually call it a curve. It's not a curve, but it's generally said area under the curve, because you can find out an area under the curve, but in your case we'll just stick to straight lines. So how would you find the area under the straight line? We'll just say this is the length of this rectangle and this is the width of the rectangle. So what are you doing exactly? You are multiplying this quantity on the x-axis with this quantity on the y-axis. You are simply multiplying 8 seconds, because the formula of a rectangle is length times width. So you are simply multiplying 8 seconds with 6 meters per second. Till now you don't know what you're doing, but if I tell you that I have told you that the units can cancel out if you want to find out. So let's see, the seconds cancels out with this because this is dividing, and you are left with 8 into 6 meters. 8 6 are 48 meters. This is the unit that is left here. What unit is this? This is the unit of displacement. So you can see that the area under the velocity time graph is giving us displacement. What exactly is happening? This is what is happening, guys. If you remember the formula, distance divided by time was equals to velocity. Now what is exactly happening? We are multiplying the velocity with time, in this case velocity into time. So this is giving me distance. So you can see the units are consistent, and also so is the formula. This area under the graph is giving me distance. Let's see another example. If I have this graph and this is my area, this is the line, this is 3, and let's say this is 6, and this height is 4, and I ask you, this is a velocity time graph. You can see the velocity initially was 0, the car was at stop, it moved till 3 seconds, it gained a velocity of 4 meters per second, and then this is acceleration, obviously there is a gradient, and then it moved at a constant velocity of 4 meters per second. This is what it did. Now if I ask you separately, part A, tell me the distance that the car moved. So what you would simply do, you would say, okay, as we have seen, since by using the formula, what you would do is you would say, okay, Adil, since the car is not moving at the same velocity throughout, so we cannot use it. However, we can use an average velocity. So you would, as we have learned, you would find the average velocity first. v1 plus v2 divided by 2. So the v1 would be 0, v2 is 4. So 0 plus 4 divided by 2. You will find your v average, which is equal to 4 divided by 2, 2 meters per second. Now you can assume that the car was having a velocity at an average velocity of 2 meters per second. Now you can use this in your formula. The formula is, I asked you the question to find the distance that the car moved in 3 seconds. So now you can say v average times time. This is what we know, this is the formula actually. This is velocity average. So you will say, okay, 2 times 3 is 6 meters. The car moved 6 meters. However, I tell you, let's not use the formula. Let's use the area under the curve that we have just learned. Because the area under a velocity time graph, a VT graph, gives distance. So if I want till 3 seconds, I'll just need this area. So what is this? This is a triangle. Triangle with a base of this and a height of this. So what is the formula of the area of a triangle? Area is equals to 1 over 2 times base times height. So 1 over 2 times base, which is 3 again, and times height, which is 4. So 3 times 4 is 12. 12 divided by 2, 6 meters. You just simply found the area here, and you can see the answer is the same, both the cases. Now if I ask you to find me the total distance, you will find the distance till 3, and then you will find the distance here, distance moved till here, and you can add them up. Now if I want to find the distance in from 3 to 6, so this is a rectangle. You should identify that this is a rectangle. The formula is base times height. Base, or sorry, base times height, or yeah, whatever you want to say it, length times width. So this is 6 minus 3. This distance is 6 minus 3, which is equals to 3. And this height is 4 of the rectangle. The height of the rectangle is 4. So this is 3 times 4, which is 12 meters. However, since we need the total distance, this triangle here was 6 meters, and this here is 12 meters. So the total area is 6 plus 12, which is equals to 18 meters. So the car traveled a total distance of 18 meters. You can also check this area using the formulas, and you will get 12 meters again. So this is how we use the area under the curve in a velocity time graph to get the displacement. Now let's see another case where it is used. Let's talk about acceleration time graph. Meters per second square, and this in second. For example, we have this line. Okay, and I'm telling you to find the area. You know the area of this line would be this. But what is it signifying? What is it giving you? Now let's see. We know that area is equals to, acceleration is equals to final velocity minus initial velocity divided by time. Here, what I'm doing, as we know, we are multiplying the quantity on y with the quantity on x-axis, which is acceleration into time. So if you can see, if I take it here, this becomes acceleration times time. What is left here? Final velocity minus initial velocity, which is exactly as the change in velocity. So for a particular line, if you calculate the area under the acceleration time graph, you will find the change in velocity in that interval. You will find how much the velocity has changed in that interval. For example, if I say I just somehow know the velocity here is 0. I cannot say this by looking at the graph. I cannot, because I only get the information of acceleration here, and acceleration is 0 at this point. And we know that acceleration can be 0 in two cases. So one of them might be that the car is at rest, which is velocity is equals to 0, or it might be that the car is at constant acceleration. But for now, let's just assume that the car is just at rest. Okay. Now this, for example, is 2, and this is 4, for example. And I ask you to find the area. You find the area. This is a triangle. This is half times base times height. So this is half times 2 times 4. This gives me 4. Now the unit, since it gives me velocity, the unit would be 4 meters per second. This means that the change of velocity in this interval is 4 meters per second. So if I say that the initial velocity was 0, the change in velocity was 4 meters. By this point, the velocity would have changed by 4 meters per second. It would have increased by 4 meters per second. So at this point, the velocity would be 0 plus the change, 0 plus 4. By this point, the velocity would be 4 meters per second. So this is how the area under the curve comes to the use. Whenever in a speed time graph, the area under the curve gives us the the displacement, and in an acceleration time graph, the area under the curve gives me speed, or the change in velocity. The change in velocity in that period. It does not tell me that the velocity is if the velocity at this point was 6 meters per second, this does not tell me that the velocity at this point would be 4. It tells me that the change in velocity would be 4. That means that the velocity would have increased by 4 meters per second till it reached this point. That means in this case, if the velocity was 6 meters per second, by this time the velocity would be 10 meters per second. 6 plus 4, 10 meters per second. So this tells me the change in velocity. So guys, we have seen how gradient works, and we have seen how area under the curve works. So revise these two concepts, and we will be moving on and talking about more graphs now, and we'll just see the real deal now. So if you have any queries, just write them down on the comments box and I will be replying to them. Thanks for watching, guys.